Alright, so in this video we're going to take a look at scalar multiplication for vectors. In our last video we took a look at adding vectors together. But a scalar is simply another name for a real number. And when we multiply a vector by a scalar or a real number, it's going to scale the vector's length accordingly, hence the name. So for instance, let's say we have the vector A has elements 3, -2, and we want to know what 2 times that is. So let's start with vector A is at 3, -2, and I think I realized how to use the arrow drawing capabilities here. So we're going to start at the origin, go over 3 and down 2, so at the point 3, -2, so over 3 and down 2. And there is vector A. Alright. Now 2 times vector A, all we have to do to get what the elements of 2 times vector A are going to be is simply multiply each element by that value, that 2. So if A is at 3, -2, that's going to put 2 times vector A at, well, let's see, 2 times 3 is 6, and 2 times -2 is -4. So 2 times vector A is at 6, -4. So if we graph that, we're going to start at the origin, go over 6 units and down 4 units, and right about there, there is 2 times vector A. So this whole length right here, it's the best bracket I can draw, is 2 times vector A. So notice that the length of 2 times vector A, if we were to create a right triangle here and use the Pythagorean theorem, the length of 2 times vector A would be double the length of vector A. And we call vectors that are scalar multiples of another, they're called parallel. So here we have vector A and 2 times vector A. Those are parallel vectors, since 2 times vector A is just literally 2 times this starting vector, vector A. So let's see what happens when we multiply a vector by -1. So we have, once again, A is at 3, -2, and we're going to multiply that by -1. So let's start with vector A at 3, -2 again. So there's vector A. And multiplying by -1 means that, we just are going to take each of these elements here, sometimes also called components, and multiply them by -1. So -1 times vector A is going to be -1 times 3 is -3, and -1 times -2 is 2. So -1A is -3 and 2. So let's go ahead and graph that. So starting at the origin, we have 3 to the left, and then 2. That's kind of not going exactly where I need it to go, but here we have negative vector A. So here's -1 times vector A, and again here is vector A. So notice that multiplying our vector by a -1 as a scalar is going to have it point in the opposite direction. So in other words, it'll rotate at 180 degrees. So we can combine our scalar multiples with the vector addition we looked at before. So that's what we'll look at here. So example 2, we have vector V is at 1, -1, and vector W is at -2, 0. We're going to find and graph each. So vector V minus vector W. Now vector V minus vector W, we can subtract the corresponding elements much like we can add them, or we could also think of vector V minus vector W as vector V plus -1 times vector W. So either way we do that, we're going to end up taking 1 minus -2. So vector V minus vector W. We're going to have 1 minus -2, which will give us 3. Or 1 plus -1 times -2 will still give us 3. -1 minus 0, or -1 plus -1 times 0 gives us -1. And if we take a look at our result, vector v is at 1, -1, so we'll do that one in red. So 1, -1 for vector v. So there's vector v. W is going to be at -2, 0. So W is at -2, 0. We could also take and add the opposite of W. But here we have v minus W is at 3, -1. So 1, 2, 3, -1. Going to end up right here. So if we look at vector v plus -1 times vector W, vector v, whoops, didn't mean to do that. Got to get out of arrow mode here. Vector v plus -1 times vector W, and I don't know why I put the parentheses there, but that would be 1, -1 plus -2 times -1 is 2, and we get 0. So we could also take this vector W and flip it 180 degrees, and that'll end up from where vector v is. We'd actually go not to the left 2 units, but to the right 2 units, and lo and behold, there is where we are. So this is vector v, this is negative vector W, and here is v minus W, the one in pink. All right, part B, again, same vectors. This time we have 3 times vector v plus vector W. So 3 times vector v, we're going to take each of these values, elements, and multiply them by 3. So 3 times vector v is going to give us 3, -3. And then vector W, we're just going to add that in. It's at -2, 0. So we're going to take this 3, -3 vector, add it to this -2, 0 vector, and let's see what we get. Well, 3 plus -2 gives us 1, and -3 plus 0 gives us -3. So ultimately, from the origin, we're going to end up at the point 1, -3. And if we take a look at that visually, 3 times vector v is going to be at 3, -3. So 3 and -3. So there's 3 times vector v. Vector W is -2, 0. So we can go -2, 0. Here's vector W. And then our result vector, our resultant vector, is going to be at 1, -3, which is where the this vector here is pointing at. And there is our resultant vector. So here's 3 times vector v in red. And our W here is just vector W at -2, 0. And then in pink here, we have 3 times vector v plus vector W. All right, last up, part C, we have 2 times vector v minus 1.5 times vector W. Well, 2 times vector v, if v is at 1, -1, so we have 2 times the vector 1, -1. And then we're going to subtract 1.5 times vector W, which I think was -2, 0. I'm getting old. Yeah, -2, 0. Okay, good. Not that old, I guess. So 2 times this vector will give us 2, -2. And then -1.5, we can take care of the negative right now if we like. -1.5 times -2 is 3 and 0. Or we could have kept the negative, and this would be a -3 and a 0. So we'd have minus a -3, which is going to end up as +3 anyway. So our result is 2 plus 3 is 5. -2 plus 0 is -2. And if we graph 2 times vector v, we'll do that in red. So 2, -2. So let me get the vector here. 2, -2. Make sure I go the right direction as well. So 2, negative 2, there's this vector. And then negative 1.5 times vector w is going to go over 3 spaces to the right and 0 spaces up. So 1, 2, 3 spaces to the right and right about there. And notice our vector ends at the point 5, negative 2. So there's, in pink, 2 times vector v minus 1.5 times vector w. All right, that about does it for this video. Thank you for watching. I'll see you later.